find the tension in each cable supporting the 6 times 10 to the second newtons category in the figure below. So it's supporting this person, right? So we want to know what is the tension in each of the cables. So I will first call the different cables, right? So we say that this cable over here will be the cable 1. So the tension in cable 1 will be the tension 1. This will be the cable 2. Tension in this cable will be tension 2. And then we have here the cable 3. So when I represent the 3 cables down here, I have this one, this other that is an angle of 37 degrees, and then we have this one. But exactly like that. Well, here we will have one force, that is the force of 600 newtons. Sorry, 600 newtons. 600 newtons. 6 times 10 to the second newtons. So I will have one tension acting in this cable, one tension acting in this other. So we have one tension acting here. And we have one tension acting here. This will be tension 2. This will be tension 1. Now, what happened with the cable 3? When you analyze the cable 3, I will make a cut, and then I will have the tension in cable 3, which balance, the force of applied force of 6.0 times 10 to the second newtons. So we can say that the tension 3 is equal to this 6.0 times 10 to the second newtons. Right? This is the tension 3. So now we're going to find tension 1, tension in cable 1, and tension in the cable number 2. So we know that this angle over here is 37 degrees. Okay. So when I make some of the forces in Y, I say that the sum of the forces in Y is equal to mass times accelerations in Y, but that this acceleration in Y is 0, the sum of the forces in Y is equal to 0. Then I have that, which are my forces in Y. I have the Y component of the tension 2. I will be taking positive those forces that point outward. So we say tension 2, XY component is tension 2 sine of 37 degrees minus what is the other force in Y, the tension 1 or the weight, so 6.0 times 10 to the second newtons, or 600 newtons, which is equal to 0. So your tension 2 would be, I will now put 600 because at the end 6 times 10 to the second is 600. So 600 newtons divided by the sine of 37 degrees, and that would be 997 newtons. So the tension 2 have a value of 997 newtons. Now we will make a sum of the forces in X, which is equal to the mass times the acceleration in X, but there is no acceleration in X, right? So this is equal to 0, so the 0 vector. So now which are my forces in X? Well, we have the horizontal component of the tension 2, I will be taking positive, the force is pointing to the right. This is a convention. So we say tension 2, x component is the cosine of 37 degree minus the tension 1 equal to 0. So I will say that tension 1 is basically equal to tension 2 cosine of 37 degree. So tension 1 is equal with the tension 2. We found that is 997 newtons cosine of 37 degree. So tension 1 is equals to, you now found this product, you get 796 newtons. So I found the three tensions in the three different cases.